year, we are in the 3 days international webinar on recent trends in pure and applied mathematics. AMMAL Arts and Science College is run by the AMMAL Educational Trust, established by the father of RAMANATHAPURam, Dr. E.M. Abdullah, in the name of his beloved mother AMMAL. He was a famous doctor, a well-known philanthropist and social worker. This institution has successfully completed 11 years of excellent academic service, and now it has been accredited with B grade by NAC. In our college, the Department of Mathematics was started at the time of inception of the college in the year 2010 with BSc Mathematics. From the academic year 2013 to 2014, the Department of Mathematics has started to offer MSc Mathematics. Now, the PG Department of Mathematics organized a 3 days international webinar on recent trends in pure and applied mathematics. Will be for students and researchers of mathematics. The main objective of this webinar is to provide and motivation for further study of research work and direction for interdisciplinary mathematics field. I invite our respected principal, Dr. SVS Amanullah Hamid, to give a presidential address.
I am very happy to participate in this international webinar on recent trends in pure and applied mathematics. I have to congratulate the Department of Mathematics, particularly HOD of Mathematics, Dr. M. Anita, and generally all the members of the Mathematics Department. This webinar is preceded by so many resource persons, particularly Dr. R. Ramar, Assistant Professor in Mathematics, University of Technology and Applied Sciences, Sohar, Oman. Next, Dr. Suresh M. Hegde from National Institute of Technology, Karnataka, Mangalore. Dr. S.K. Vaidya, Saurashtra University, Rajkot, Gujarat. Dr. S. Balamurugan, Government Arts College, Mangalore. And Professor, Department of Mathematics, University of Kerala, Dr. G. Suresh Singh have participated in this webinar. It's my duty to welcome and I have to give warm reception to the various universities and also particularly from Oman. Therefore, this international seminar, I have to congratulate the participants and also students and also professors. This type of webinar will help them to understand in depth about mathematical problems. The main objective of this seminar is to motivate on research work. That's very important. When we conduct this type of seminar, actually this will induce participants and motivate them to participate in this type of webinar, which will help them to understand the mathematics very well. Now we are very much interested in the research field. When we study in depth, when we are using the mathematics for future studies, that will help them to understand various aspects of this mathematical field. Naturally, that will help them to lead them to the research areas. That is, nowadays it is needed. Under the leadership of Vijayendra Singh, Minister of various field in the research, they have conducted a 3-day meet from 7th to 9th to motivate the research and innovation in our students and also young scientists. This 2047, we are going to reach the 100th year of independence. In order to remember these days, so many steps have taken by the central government. Therefore, in this now we have started this webinar as per the central government's order, imagining of 2047. We are also conducting this type of webinar. Then, with the help of so many resources from abroad and also from our countries. Therefore, I have taken this opportunity to felicitate the persons who have taken steps to conduct this seminar. Wish you best of luck. God bless you. Thank you very much for the chance given to me to felicitate all the participants and so on. Thank you very much.
Thank you for your speech. It gives an energetic beginning for this webinar. The keynote speaker of this session is Dr. G. Suresh Singh, Professor in Department of Mathematics, University of Kerala, Trivandrum. He has 31 years of teaching and research experience. He published 91 research articles in international journals and 54 in national journals. He delivered more than 200 invited talks. He produced 32 PhD scholars, 83 MPhil scholars, and 99 MSc students. He evaluated more than 180 PhD theses. He is an author of a book, Graph Theory, and the editorial board member of GSTF Journal of Mathematics, Statistics and OR, Mavana Journal of Science, Journal of Graph Labeling, Advances in Mathematics Scientific Journal. Also, he received many awards like Bharat Gaurav Award, Glory of India Gold Medal, IMRF Excellence Award, ISEF 2020 Research Excellence Award. With this brief introduction, I would like to welcome our resource person, Dr. G. Suresh Singh, for sharing his views on graphs as models. You're welcome, sir.
Thank you, madam, for the nice words posed against me. First of all, I take this opportunity to thank the organizers for giving an opportunity to share some mathematical ideas with the great audience. And all, now I wish to share my screen. Okay. Today our talk is recent trends in pure and applied mathematics. So I take 2 or 3 pure mathematical concepts and use some application related to that parameters. For that, the topic chosen was graphs as models. And we know about models, knowingly or unknowingly. Actually, what do you mean by a model? One small abstract is representation of unknown or unfamiliar objects or event or a problem through a known or familiar method or technique system is known as a model. The first question is why models? For that, we will say find the height of a tower. The next one is find the width of a river. Further, find the mass of the earth. Or then find the temperature of a surface. And the last one, estimate the population of India in the year 2030. These problems can be solved, but some initial conditions are given. For example, first one, it is going to find the height of the tower, but without climbing it. Find the width of the river without crossing it. Find the mass of the earth without using a balance. Find the temperature of the surface without using a thermometer. Estimate the population of India in the year 2030. Condition is without waiting, or one can solve, one can determine the target. But the condition given must be applied. Then how will you solve? These are all real life problems. So, but using the or adapting the given condition, it is very difficult to solve these problems in the domain via relationship. We shall see the method of model. In this particular event, the model means I use mathematical modeling. Because we are all people have the knowledge of mathematics, and most of the people assembled here are mathematicians. So I want to take mathematical models. So before we enter into it, we must know what is mathematical modeling. Mathematical modeling essentially consists of translating real world problems into mathematical problems, solving the mathematical problems, and interpreting these solutions in the language. This is the basic idea behind the construction of a model. And we shall see the configuration technique. This is one real problem. We have to solve this real problem in the domain where it exists. In most of the times, it is very difficult to solve the problem or get the solution in the domain where the problem is being available. So immediately what we have to do is we have to convert this real problem into a mathematical problem. The question is why we are converting real problem into a mathematical problem. Once, if you are able to design the real problem into a mathematical problem, in the field of mathematics, we have so many logics, so many ideas, so many techniques, so many methods or algorithms or congruences to get the solution of the mathematical problem. The condition is without real weight. We have to get the approximate solution now itself. Then how can we get it? Unless if you are convert this as a mathematical problem, or unless if you are giving a suitable model, you cannot solve the real problem. So for time being, we are taking let x of t be the population size at time t, and let b and d be the birth and death rates. P means the number of births, D means number of deaths per individual per unit. So immediately you can form one differential equation. Px, the change in population with the change in time t equal to the difference between bx and dx. That is, difference between b and d, that may be taken as a, then it is equal to ax. That is, dx by dt equal to ax, where a, b, d are constants. On integration, what will we get? We get x of t equal to x of 0 in the e power 8. Now, this quantity gives the solution for the original problem, especially first in mathematical problem, then with the interpretation. What is the interpretation? So the population goes exponential if a greater than 0. In this equation, if a greater than 0, you will get the value higher and higher. If a increases, that total value will higher and higher. A decreases, it decays. Higher and higher means the population grows exponentially. That means population grows. And if a less than 0, population decays exponentially. And it remains constant if a equal to 0. A equal to 0 means number of births and number of deaths in the particular period is same. Therefore, the difference is 0. Therefore, x of 0 in the equals. The population will remain constant. This is one powerful model. Still, our government, and not only in government, most of the government in the world, they are using this technique to estimate the population of their country. And another one geometrical is one of the examples of geometric modeling was involved in use of parabolic mirrors for burning enemy ships by Archimedes by concentrating sun parallel rays in time. We know the typical character of a parabola. A parabola has a unique focus. So, if any rays happens to fall on a parabolic mirror, all rays reflect and concentrate at a single point, that is at the focus. So, if you focus the parabolic mirror on the enemy ships, then you can burn the ship. A typical experiment we can have is, in my childhood days, I did it. If you take a lens and holding some cotton in your hand, and if allow to pass the sun rays through the lens and falls on the cotton, immediately it gets fire. This is a very simplest lesson. But if you use hyper-focus parabolic mirrors, this also can be done. This is one geometrical model. And now we are going to get into the application side. Most of the applications are with respect to graphs. Now, for our application side, the model I have used are graphs. What is a powerful study graph and a graph theory. Suppose I ask one question, not define a graph. What do you mean by a graph? Suppose in some places I ask, what do you mean by a graph? Immediately people say that graph is an ordered pair, T equal to A comma E, where E is a non-empty set, E is a set of unordered pairs of elements of V. The set of V, the set V is known as a vertex set. The set E is known as a edge set. The ordered pair, where V comma E is called a graph. This is a traditional definition for a graph. But what do you mean by a graph? Graph is nothing but a representation. So the next question may be asked is, representation of what? So graph is nothing but the representation of a relation. Representation of a relation. So in order to understand detail, we must know what is a relation. Everyone knows. Relation is nothing. Any subset of a Cartesian product is a relation. Any subset of a Cartesian product is a relation. So now correlate these two. This is time being dimension. The traditional dimension I already told. Whether they are same or different. They are nearly same. Because we are considering one non-empty vertex set and another one edge set. What is an edge set? Is nothing but subset of V cross V is nothing but subset of V cross V. If you take V cross V in the original sense, the graphs so obtained are known as directed graph. But you are getting a graph, that situation may be called as a direct graph. For time being, when we are defining graphs, we take V is an non-empty set and E is a set of unordered pairs of elements. So direction is relaxed. That is the only difference between directed and undirected. Okay, here the relation means qualitative relationships. Some relations I mentioned are typical qualitative relations are likes, hates, superior to, belongs to, intersection with, joined to, defeated, father of, or son of, wife of, mother of, whatever it may be, prerequisite for, connected by, influence on, increase of, decrease in, and so on. So many relations. The beauty is any system in the world, if it has a binary relation, any system wants a binary relation can be modeled as a graph. That is a powerful fact here. Any system in the world, if it associates with a binary relation, immediately the whole system can be labeled or can be drawn or can be represented as a graph. Now, first we shall see one or two known examples, familiar things. In the 18th century, the medieval city of Königsberg in eastern Russia contained a central island called Nifno, around which the river Rigel flowed before dividing into two. The four parts of the city were interconnected by 7 bridges, as displayed. I will show it. The question of the citizens was: is it possible to find a route traveling each bridge exactly once and returning to the starting point? In short, in the region where there are 4 land portions joined with 7 bridges. The question is it possible to travel through all the 7 edges exactly once and reach the place where you have started? That is the question. In the olden days, many people physically tried to get the answer or to solve this problem, but no one could. So, the father of graph theory, Euler, has given the solution for this problem. This is the situation. There are 4 land areas: capital A, capital B, capital C, and capital D. They are all other areas are surrounded by water, and these 4 lands are joined by or connected by 7 bridges: 1, 2, 3, 4, 5, 6, and 7. The question is, if you start from here, you have to cross all these or pass through all these 7 bridges exactly once. That is the condition. Exactly once, and you should reach here finally. Is it possible? And Euler convert this real situation. This is a real problem. He convert this into a mathematical problem by pointing the 4 areas as 4 vertices of a graph and 7 bridges as 7 edges associated with these 4 vertices. And immediately he said that it is highly impossible, or it is not possible, to travel through all the 7 edges exactly, 7 bridges exactly once and reach the place where we have started. But he gave that solution only, but he didn't give any proof of that. So people were able to know it is not possible, but don't know how. But after 30 years later, this is at 1736, he gave the solution. But after 30 years, one of his students, Euler's student, gave the proof. That is known as the characterization of an Euler graph. That is, a connected graph G is said to be Eulerian if and only if it doesn't contain any or otherwise all the vertices are of even degree. A connected graph G is said to be Eulerian if and only if all the vertices of the given graph of even degree. But for the pride of his master, he gave the full credit to Euler. That's why it is known as Euler solved this problem. But he gave the solution of the problem in 1736. And we shall see another known situation that is known as utility problem. A commercial agency wishes to connect 3 houses ABC to 3 utilities, gas, water, and electricity. For safety reason, it is necessary that the various connections should not cross each other. Can the connections made, or up to what extent it is possible? Okay, now see the situation. One agent can give, this is a small example, small version. There are here 3 commodities and 3 houses are considered. The 3 commodities are gas, water, electricity. Houses are A, B, C. A single agent have the strength to provide all these 3 commodities to all these 3 houses. So, certainly, it can be given like this. Now, all the 3 commodities are supplied to all these 3 houses. The problem here is, except the endpoints, there are so many crossings are available in this connection. The question is, up to what extent the crossings can be eliminated? Why we are posing this problem? Let's see. Suppose there is a leakage in this gas pipe. Suppose gas given to C through this pipe. Suppose there is a leakage in this pipe here. And this is electricity to A. Fortunately or unfortunately, a bird happened to sit on this electrical wire. It's like a spark will happen. But already there is, so immediately there is a blast happen. So in order to avoid such bad events, we are in need of eliminate the crossings. So here the question is, how many crossings may be avoided? Suppose 3 commodities are given to 3 houses. See this one. Now this is a gas, this is a water canal, and this is electricity. Now suppose if we give the connections like this, nothing happen, no problem. But see one thing, this water connection is not provided to the house B, and all other commodities are given to all other houses. So it immediately tells that except this one crossing, all other crossings can be eliminated in this special graph. It may be called as K33. So the reality is, if you convert the given problem or real problem into a graph theoretical problem in a proper way, and if you use so many graph theoretical algorithms are available in planarity here, the main concept is up to what extent the graphical structure can be made as a planar. Here now it is a planar. If you give this one connection, there are so many planar algorithms are formed to available to compute such a process. If you use that, immediately you can avoid the problems in the real life situation in the case of utility problems. And you shall now see another one graph. A signed graph is a graph in which every edge has a positive or negative sign associated with it. The positive and negative signs refers quality relations. In some 4 or 5, before the 4 or 5 slides, I mentioned some quality relations. As a mathematical sign, there are 2 signs, plus and minus. Plus stands for the positive qualities, and negative and minus stands for the negative signs, negative qualities. Normally, we know that what is a weighted graph. In a graph, if all the edges are associated with some real numbers, that maybe the real numbers may be called the weights, and the resultant graph is called as a weighted graph. Here, if you assign signs to all the edges of the graph, the resultant graph may be termed as a signed graph. So, what is the use of defining or constructing such a graph? Normally, signed graphs have been used political scientists to study international relations often. More than ourselves, social scientists use such a situation where the vertices correspond to the nations and the edges join pair of nations which are allied, maintain diplomatic relations, agree on a particular strategy. these qualities are positive quality. Positive quality. Then we will give positive. Otherwise, the edges may be given. Now we are going to see a small case. Before that, why we are associate scientists use this sign diagram? The main intention of the usage is to study tension analysis. Tension analysis can be studied through these kinds of graphs. Next, we are going to see when three peoples happen to work together, what are the different situations, what are different types of tension analysis. Why we are studying tension analysis? The reason is, suppose our government of India is considered, we are having so many borders with the other countries. So, once the government is able to compute the tension caused in such borders, it helps the government to deploy the soldiers. At which places large number of soldiers must be deployed, which places medium number of soldiers is needed, and which places less number of soldiers are enough. In order to determine these things, this type of tension analysis helps the governments to simplify their target. Now we are going to see three different situations that can occur. Three people, the different situations. When three people happen to work together, the possible different situations are four. The number of four different situations. Here, A, B, C are the three different persons. In this picture, we are having negative signs in all edges. That means no one is ready to agree with each other. Suppose, to understand the concept easily, just as your college principal select three of his colleagues and asked them to put up this academic title for the college. Three teachers means A, B, C. None of them are ready to cooperate with each other. Then what happens, you know? If the academic year comes to an end, the project will not be completed. The reason is, if A proposes something, B discloses, C discloses. Nothing can be decided here. So, leave it. And come to the next one. Here, each teacher is ready to cooperate, or ready to accept, ready to align with the decisions of the others. So, the immediately, in a shorter period, the project can be completed. This is fine. Okay. Now leave these two. Consider these two. This one and this one. Now the question is, among these two, which one is feasible or which one is better? In such a webinar, we could not interact, but in the offline, we could enjoy and interact with each other. But anyhow, the question is, which one is better? Normally everyone would say, this is better. Everyone can identify. Among these situations, this situation is better. If I ask what is the reason, immediately mathematically, they may answer, here there are two plus signs and one minus sign. Here there are two negative signs and only one positive sign. But that's not true. This is not feasible. This is better than this. I don't know how many of you are ready to accept. This is better than this is true. The reason is, come to this one. Here, A. They are ready to accept both C, B and C. But B and C are not ready to accept. What happens? Suppose, consider this. A is a child in a family. A is a child in a family. B is the father of the child. C is the mother of the child. Father and mother, they are not ready to accept or agree with each other at any cost or at any time. But the child wants to accept both the father and mother at a time. So, if the father asks the child to go 3 steps backward, immediately the mother will ask the child to come forward 3 steps. So, what will be the situation of this child? Child wants to respect both father and mother equally. So, he cannot move the place where he stands. So, nothing can be done here. But come to here, A propose something, immediately B accepted. B propose something, A accepted. C is the common enemy of this. We know enemy of enemy is a friend. Local language. And in mathematically and in a democratic country, if there is a 2/3 majority, anything can be passed. So among these three, these two people are ready to work together, ready to accept together. So something can happen here, something can be done here immediately. So this is vast and this is better. This is better than this situation. So suppose there are, this is only 3 people happens to work together. Suppose there are 50 people, 100 people, 1,000 people. What will be the situation? So once if you are able to plot them in the help of SYED graph, there are so many algorithms which will give the positive relations and a set of negative relations. So immediately the situation and the tension occur in that domain can be easily sought out. And another one application is of graph is a tree model. Tree we know a connected acyclic graph is called a tree. Tree means the graph must be connected and it doesn't contain any cycle. Such a graph theoretical structure is known as trees. One small application, one demonstration to a known one. The following tree depicts a part of administrative structure, in particular academic side in Indian universities. Suppose a vice chancellor is here, the chancellor is here, C1, C2 are the deans, D1, D2, etc. D3 to are the head of the departments. D1, these are all the respective faculty members in the departments. Now, the vice chancellor wants to get some intimations from all these faculty members. All these faculty members. To get whether he has to contact all these separately. No. The vice chancellor, if he sent or request some intimation to deans to get the faculty, immediately the dean send the message to the head of the departments. Each head of the department can get the information from their individual faculty and they can send it to, not directly to the vice chancellor, into the deans. Deans send the same to the vice chancellor. So the vice chancellor is time being satisfied because he got information of every faculty from all the departments without approaching them or without contacting them. So it is clear that if these two groups, C1s, CIs and DIs are there, it is enough to get the images or results from the, each EIs and pass it over the vice chancellor. And another one is, if in graph theoretically another concept is these two sets are combine these two sets, immediately this will act as a dominating set because domination parameter is one of the important areas in graph theory, and especially in Tamil Nadu, most of the people are doing something on dominations. So these two sets immediately stands as a dominating set. And another one example or application of our mathematical for a real life situation. In our school ancient days, we have studied a chemical molecule can be represented as a graph by graph whose vertices correspond to the atoms and edges correspond to the bonds. Now, some alkanes are considered in order to calculate the or identify the typical property in chemistry. We all know isomers. Isomers means they have the same chemical formula but different chemical structure or different chemical property. For that, they use graph as a model. Suppose first alkane methane is considered CH4, that is in general CnH2 n plus 2. Now n equal to 1 CH4, H2n plus 2, n equal to 1, 2 plus 2, H4, methane. So immediately it can be, that means CH are plotted as 5 vertices and give, there are 4 bonds between C and C, give 4 edges, immediately you are getting a graph, but particularly this is a tree. Similarly, there are so many others, and in order to study or compute the number of isomers, immediately once the graph structure is get, every end vertices are the hydrogen compounds. You can for computation, what you can do is simply leave the hydrogen atoms and consider only the carbon graphs, each of which these carbon graph is a tree in which every vertex has degree 4 or less. This is the important point. If you leave the hydrogen atom, what you are getting in the resultant graph is a carbon graph, but which is not In graph theoretically, it is nothing but a tree with one property. Whatever may be the alkanes, remove the hydrogen. You can verify the tree. Every tree of vertex has degree 4 or less. So number of isomers is general formula CnH2n plus 2. So n equal to 1, what happens? N equal to 2, there is a tree. N equal to 4, n equal to 10, n equal to 100. There are trees. But the situation is, how many trees can be obtained with this property? Such that every vertex has degree 4 or less. That number of isomers can be available in that area. So in chemistry, for the calculation of isomers, they are converting their alkanes into their organic compounds into a graph, and they are getting the answer for their original problem. And this is in chemistry. Suppose physics is considered. The same graph theory helps as a model. We know there are two current laws given by Kirchhoff. Kirchhoff is not exactly a physicist, he is a great mathematician. Only through the help of graph theory, you'll be able to propose two current laws. In a directed graph, you know the degree is split into two components. In a graph, a degree means number of edges incident on that vertex is known as a degree of that vertex. But as far as directed graph is concerned, the degree of a vertex can be split into two components. One is in degree and one is out degree. If the arrow of the at edge is towards that vertex, it is an in degree. Suppose the edge with the outgoing arrow, that is out degree. The in degree, if you take the in degree as plus, the out degree as minus. Now, the first Kirchhoff's current law is, in an electrical network, the algebraic sum of current flows towards a junction is always equal to the algebraic sum of the current flow away from a junction. Here, junction means when an electrical network is considered, the electrical apparatus are converted as points, are plotted as a point, and the electrical network connections are the edges of the corresponding two equipments. So the electrical network now can be transformed as or represented as a digraph. And in a digraph, you know that if you consider any digraph, the total sum of in degree is always equal to the total sum of out degree. Not the total sum of in degree of a vertex, the total sum of in degree of a graph is always equal to the total sum of out degree. With the help of this fact, may we propose the first law, the algebraic total means the algebraic sum of current flows towards a junction, that is total in degree, is equal to algebraic sum of the out current flows away from a junction, that is out degree. And if the total sum of in degree is equal to total sum of out degree, if you add these two, what happens? If in degree is taken as positive, out degree is negative. If in degree is taken as negative, out degree is positive. So if you add this, the total effect is 0. With the help of this idea, he immediately proposed the second current law, that says that in a closed electrical network, the total EMF produced is 0. In a closed electrical network, the total EMF produced is 0. And Madam, up to what level I can extend? Hello, Madam? Up to what extent I can extend? Up to what time I have to finish? Please. Now it is 10:50. Shall I take 15 more minutes?
Yes, sir, sure. You can take now.
Okay, thank you. Okay, now consider the tournament. A digraph whose underlying graph is complete is called a tournament. Suppose you have take a digraph, remove all the directions, the resultant one is a complete graph, it is called as a tournament. Such a tournament helps to propagate the results of a round robin tournament. Because here, A, C, B. In a round robin tournament means each player or each team must be played with all other players or all other teams. So here there are these graphs represent the result of a tournament. Here, for example, A, B, C. There is one arrow. The arrow indicates that who beats who. Here, there is an arrow from A to C means A beats C, A beats B, B beats C. What is the specialty of this? Suppose there are 3 or 4 players or 4 teams of players, it is easy to write when the result of match with A and B is this, A and C is this, etc. etc. But there are 50 teams or 100 teams. If you give the result in a verbal manner, it is very difficult to understand everything. But instead of that, if you plot that number of points and you give this relation, it is easy to understand the result. So, diagram, yeah, and this is one of the highest application of our powerful model. In the modern world, each and everyone face the problem of disposal of the waste. Waste management is a high risky problem in the whole world. Now we are seeing a small portion of the solid waste disposal problem. This model is known as solid waste disposal model. The signed graph below is simplified version of one used to describe the relationships between the variables in the solid waste disposal problem of a city. Here we are considering some parameters. These are, I can't say that these are the only eligible parameters. Some other parameters may also be included in the system, but these are the main parameters. So that's why this is a simplified version. These are the highest important parameters. So that are taken under my consideration. Here, B is the amount of bacteria per unit area. C is an amount of migration into city. D is the number of diseases. M, amount of modernization. P, size of population per unit area. S, amount of sanitation facility. W stands for amount of waste. These are the explanation or definition of these parameters. Now see this diagram. In some edges, there are signs, positive and negative signs are assigned, and some directions are also. If you are giving one direction, that means if there is a change happens in this parameter, it causes a change with this one. Immediately we give the edge of the line between the P2. P2 means there is a change occurring. This causes a change in this particular or this parameter. Immediately we are drawing these two parameters. In this way, all these are joined. And here we are giving a plus sign. Plus indicates that here, if there is an increase in this parameter, causes an increase in this one, then immediately we will give plus. But if an increase in this causes an increase in this parameter, we will give the negative sign. In this way, the plus and minus or negative signs are positive and negative signs are assigned for all the edges. Next, we will see. Starts with one parameter P. This is the parameter P. P is nothing but size of population per unit area. Okay. Suppose there is an increase in population size in the unit area. In a particular time, if there is an increase in P, what happens in the parameter W? Immediately there is a change in W. That's why they are joined. And if there is an increase in population in P, ultimately causes an increase in W. W is nothing but amount of waste. The increase in population in one area causes an increase in amount of waste in that particular area. Therefore, it is positive. Let's come to this one. If there is an increase in the amount of waste, immediately the number of bacteria produced in that place will be increased. That's why we are giving positive or plus sign associated with this edge. And if the bacteria in that area, amount of bacteria in one particular area is increased, the number of diseases occurred in that area always increased. Increase of bacteria increases the number of diseases. Therefore, we are giving plus sign here. Now, come to this. Consider this edge D2P. If the number of diseases increased in particular area, what about the population in that area? Automatically, it will be decreases. If number of diseases increases, it may cause so many deaths. If else the effect of corona COVID-19. So it is easy to understand. If there are increases in this, automatically causes an decrease in that population. So now we obtained a cycle P to W, W to B, B to D, D to P. There is a cycle. The equivalent here is it starts with an increase in population, causes increase, but causes a decrease in P. Starts with an increase and ends with a decrease. We are getting a cycle. Such a cycle is known as negative feedback cycle. We are getting one feedback, but this cycle is a negative feedback. That is, increase of population decreases in the population of the same area. This is a negative feedback cycle. And come see another one. Suppose P2, yeah, P is the population size, M is amount of modernization. Suppose consider one city, all of a sudden happens to increase in population in that city. Then what will be the government to do? Whether the government is intended to increase the modernization facility of that city or decreases the amount of modernization. That is the question. So everyone, obviously it is clear that if population size is increases in a city, government take measures to increase the amount of modernization. Therefore, it is a plus. Increase causes increase. And in one particular area, suppose the modernization facility is increased, what about sanitation facilities? Modernization facility, amount of modernization is increased means sanitation facility is increased. That's why we are getting plus. In one particular area, if government or any private or any company increases the sanitation facilities, what about the amount of disease in that area? If we increase the sanitation facilities, automatically there will be a decrease in the parameter D is number of diseases. Suppose the number of diseases decreases in a particular area, immediately what about the population? If there is a decrease in P, immediately there is an increase in P. Now we start with P and ends with P, P to M, M to S, S to D, D to P. Another cycle. Here we start with the increase and ends with also a increase. Starts with increase and end with increase. So such a cycle is known as positive feedback cycle. Such a cycle is known as positive. So the government will sort out the positive feedback cycle and the negative feedback cycle. Wherever the cycle is positive, government don't bother about that area. And wherever the government happens to get a negative feedback cycle, immediately government take remedies or take measures to get it positive. So such a model is a very powerful and very useful model. And the one fact is, throughout India, we are using till this day, we are using this type of model for solid waste disposal problem. Not only in India, most of the countries in the world, they are following this system for their solid waste disposal. Suppose the parameters may be increased, not never it will be decreased, because these are the very compulsory parameters, and some additional parameters may be also taken into consideration. But this is a one simplified and a very powerful model. And immediately I will propose one tree model. This tree is used to sort out the length of a given sequence. Too long here the length is this one, but the sequence given is 5, 11, 6, 1, 3, 9, 10, 4. This is the first level where given sequence are plotted in vertices of a tree. Then for the next levels, these vertices will be adjacent to it. All these vertices, if the value is more than or larger than this one, in that manner, the second level is obtained. The same third level is obtained. The fourth. That means only from this is the starting question. This is a given sequence. This one and this one given, because all other cases terminated before this, and this is the last level. Only two sequences, that is 1, 3, 9, 10, and 5, 6, 9, 10. These are the two longest sequence, length of the longest sequence obtained for the given sequence. And simply I will, because our aim is recent trends in pure and applied mathematics. one of the important and recent applied structure is structural trees computer. In Fortran language, the tree structure is used for their file execution. And the final one is finite state of a machine. This is a input in machines. This is the input that is in a machine. You have the data input. Machine means suppose the starting type of machine, that is storing machine or a calculator is considered. A calculator considered, some operations will be given. For this input, the operations carried out and they give the output. Suppose 4 is given, 3 is given, 4 and 3 is given. The machine command is multiplication. The output you will get it all in the calculator. Suppose these are 5 or 6 digit numbers are given, 5 or 6 digit number given, multiplication or addition or any other operation, the output will be the given answer. And some other machine based with this, a combine harvester is a machine whose input are the corn stalk in the field and whose outputs are the resulting bales. The coding machine is concerned, a machine whose input are the words to be encoded, the output will be the encoded words by using the password or using the key. The gas pedal of a car may be considered as a machine where the input pressure applied by the foot. If you give acceleration by your foot, there is a speed in your increase of speed in the car. These are some. And finally, how pure and applied myself. You know, Archimedes. Archimedes is otherwise known as ready reckoner, a father of ready reckoner. Because always, whenever he goes everywhere, anywhere, he have a briefcase. That briefcase is fully loaded with sand. Sand is a pure one. And wherever he sits, he uses his finger to compute something. To do some smaller calculation, he uses this sand by his finger and get the result. And the sand is a pure one. And the applied structure is, now you're all seeing my lecture, hearing my lecture, seeing my videos through your laptop. But what is the relation? Now we are also carrying sand, not in the original form of sand. This laptop, so many components under this is made up of silica. Silica is derived from sand. Sand is the pure one. Now silica is applied structure. Now you are using the applied structure to do our calculation, do our works in a faster way. So thank you one and all. If you have any doubts or clarification, please ask me.
So thank you, sir. I invite Mr. Sendil Kumar.
The way of understanding of graphs models gives here great value to us. Thank you, sir. Thank you so much for making your talks most informative and interesting. Because of our department, I am indebted to thank our keynote speaker, Dr. G. Suru Singh, for his successful completion of session 1. Thank you, sir. Next, I thank our participants for their involvement and interesting queries. Thank you, participants. We will meet in the next session that will be held on today at 3 p.m. Once again, I thank one and all. Thank you.
Thank you. Madam, shall I
Thank you, sir. Thank you for your support. Thank you, sir. Thank you so much.
Okay, thank you, madam. Thank you.